Hi everyone, this is Dr. Swaminathan. So this session, we will discuss for the continuous process, for the continuous learning from the Bode plot. So symbol 0 at the origin, the Bode plot will be drawn 1 plus 1 j omega t for the symbol zeros, and for the comparison you can get the n infinite poles and n infinite zeros for the g of h of s, that is 1 by s plus 1 omega n. So instead of s, is just to substitute the value j omega, then you can get the m and also pi, that is m in dB, and pi actual, that is pole actual, that is m means nothing but magnitude and pi means nothing but phase angle. So this is a simple comparison between the n finite poles and infinite poles. Same thing for another comparison, n poles at origin and n zeros at origin. So here you can get same thing, 1 by s power n, you just substitute the value s is equal to j omega, and right hand side also same thing, s power n, that is s is equal to j omega, to convert the s domain into angular frequency, that is a frequency domain, and from this you can calculate the s and pi. So this is the comparison between the n poles at origin and the n zeros at origin. And next, steps to sketch the Bode plot. Express the given g of s, h of s in time constant form and draw the line 20 log k dB, and draw the line appropriate slope representing the poles or zeros at the origin, then passing through the intersection of omega is equal to 1 or 0 dB, that is the third. And the fourth one, shift this intersection point 20 log k line and draw the parallel line to the line from the step 3. And next, change the slope of this line of various corner frequency by the appropriate value. For pole and slope must be changed by plus 20 dB. For example, 0 slope means changed by plus 20 dB decade. So continues this slope line till intersects the last corner frequency. And next, prepare the phase angle plot and table. Obtain the table for omega angular frequency and the result phase angle pi r by actual calculation. And last, seventh point, plot these points and draw the smooth curve obtaining the necessary phase angle plot. Gain and phase margin. So gain margin means a factor by which a system gain is increased to bring the system to the verge of the stability. Gain crossover means omega gc, and the frequency at which the magnitude is equal to 1 in linear and 0 in dB. Phase margin means additional phase lag required to, as a system omega gc, bring the system into the stability. So that is called phase crossover. So here gain crossover and here the phase crossover. So here the frequency at which the angle is minus 180 degrees. So this is called the phase margin. And here this is the Bode plot curve. For magnitude is the upper side and lower side phase angle. From this gain margin, that is 20 dB, and the phase angle, that is phase margin, will be the 0 degree unstable. So that is a gain crossover. Next, the gain margin and the phase margin comparison. Gain margin is nothing but is a factor by the gain is less than the neutral stability value. And next, the phase margin is another quantity that is used to define the phase margin is how well the stability conditions are met in the given system. So it is determined by how much phase off exists. So from this you can calculate this gain margin and phase margin. Next, crossover frequency for the gain factor 1, where both the input and output are at the same voltage level. The impedance is known as a unity gain. So same means that is called unity gain. And the frequency response in practical, we can easily evaluate how gain the changes affect the certain aspects of the system. So this is called the gain crossover frequency. This is the example of gain crossover frequency level. And next, g of s and h of s, based on these functions, you can make the different omega value for the different angle level, and just to make this phase angle and magnitude for the different values, and to find the total angles you can get this phase value from the factors and the corner frequency and the different functions of phase angle and magnitude and asymptotic logarithmic symbol, and you can get the phase angle. So here look at this, pi is nothing but the phase angle. You can get the formula minus 90 degree minus tan inverse omega and minus tan inverse of that's p by a. Then you can get the result phase angle for the different value for substituting omega is equal to 1 and omega is equal to 4, 5, 5.5, 6, 8. Based on this omega value, just substitute the omega into the above equations, then you can get the different phase angle value. So from this you can draw the phase angle value. Then you can draw the Bode plot in the semilog graph sheet. Thank you. This is called the Bode plot. Thank you.